All right, this is one of those specialty problems that doesn't show up too often, but it's there and it's something that you probably should know. Uh, it's on bases, writing numbers in different bases. Something you probably haven't thought about too much. Our number system is based on tens, and like the number I have for number one right there, 763 base 10 is just 763. Okay, because that's what our whole system is based on. So just to have you think about this a little more, this really means 700s. This is how you learned it back in second grade probably. Plus six tens plus three ones. Well, where does this really come from? Well, 700s is 700 plus 60 plus 3, which gives us the answer 763, okay, in our base system. This three ones comes from 10 to the 0th power. The six tens, 10 to the first, 700s, 10 squared. I'm going to kind of show this like using a kind of a table like this and putting in the numbers 763 like this, 700, six tens, and sorry, three ones. And that's how I'm going to kind of show the next few problems. I'm going to set it up this way. It's kind of a different way of showing it than what I've seen in the literature and the different problems that the book shows us or that the math counts sheets shows us. I think this might make some sense to you. Let's try it. All right, 3104, 3102 in base 4. Let's rewrite it in base 10. Let's start with, because it's base 4, I'm just going to write 4 to the 0, 4 to the 1, 4 squared, 4 cubed. You can go on forever, as big as the numbers that you need. Right, no, we just need 4 of these. There's 1, 2, 3, 4 placeholders. So 1, 2, 3, 4 placeholders. We're not going to need this one. Okay, so if I just do this, keep it in mind that this is, maybe I'll write it this way. That's a 1, that's a 4, that's a 16, and that's a 64. Okay, and I have 2 sets of 1s. I have 0 sets of 4s. I have 1 set of 16s. Maybe I'll do this. Maybe that might help. And I have 3 sets of 64s. Well, you simply multiply those together. 3 times 3 sets of 64s is 3 times 64. So 192. Plus 1 set of 16, plus 0 set of 4s, plus 2 sets of 1, 2 times 1. And just add those together and we get 210. Okay, so this is 210 base 10, or just 210, because base 10 is 210. So there we go. Now what if we want to go in the opposite direction? So let me erase this, so I have some space to work here. And let's take that 210 and work it the opposite direction. So like if we started with 210 and I want to rewrite it in base 4, what would happen? So I'm going to say, if you want to write the 4 to the 0, 4 to the 1 like that, I'm just going to write 4, actually I need to start with 1, 1, 4, 16, 64, and I'd keep going if I had to. But I only have, and I don't know if I need to yet or not, but I look at the 210, and if I say, what is 64 times 4, that'll give me 256. Well, 256 is too big. Like how many 210s go into, or how many 256s go into 210? It's not going to work. So we're going to start this way. And I'll just say, how many 64s? I don't know the best way to display this. If you have a better way of coming up to display this, let me know. How many 64s go into 210? And 3 of those fit. And then I say, well, what's 3 times 64? And that's 192. And I say, what's left over? Okay, well, there's 18 left over. Okay. And I say, how many 16s go into that 18 that's left over? It's kind of like long division. How many 16s go into 18? 1. 2 left over. I'm just kind of putting my leftovers here. And so 2 left over. How many 4s go into 2? None. I still have 2 left over. how many ones go into 2, and there'll always be, this will always work out here, 2. So my final answer then is 3102 in base 4. A little harder to go in that direction, I think. Okay, let's try another couple problems. Let's say we have this number, we want to rewrite it in base 10. Okay, so if we take our base 5 and write 1, 1, 5, 25, 125, 625, let's keep going that way. That should be far enough. We have let's see, 1, 2, 3, 5 numbers. 1, 2, 3, 4, 5 numbers. So going this way, we know we're good. And if I just put those numbers in, 2, 1, 1, 4, 3, it's pretty easy just to multiply it out. Okay, so I'm just going to say 2 sets of 625 plus 1 set of 125 plus 1 set of 25 plus 4 sets of 5 and 3 sets of 1s. Add those all together, and it's 1423. So you could put base 10 if you want, but base 10 is our number, so you can just write 1423. All right. Now go in the opposite direction. Again, it's tougher. Like this problem I just did now, it's pretty easy to line up. You just simply plug in the numbers and multiply and add together. This way you have to think backwards, and it is tougher. So now this is a pretty big number, 28,475 in base 3. Now the smaller the base and the bigger the number in base 10, the longer the number is going to be. I haven't really brought this up, but in base 3, all the numbers are going to be 0s, 1s, and 2s. You're not going to have any 3s or up. Just like in base 5 here, all the numbers are 4 and under. In base 8, all the numbers will be 7 and under. So that's something to look for. So we're going to have only 0s, 1s, and 2s. So I'm going to set this up. This is going to be kind of long here. I need a 1, a 3. I'm just going to keep multiplying by 3. So 27s, 81s, 243s, 729s, 2,187. Multiply by 3, 65, 61. Multiply by 3, 19,683s. I don't have to go any higher because my question I'm going to ask is how many 1963s go into 28,000. The next number is double, times 3, so we're looking at like 60,000. How many 60,000s go into 28,000? It doesn't go into it, so I can stop here. All right, this is a crazy number. Crazy problem. All right, how many 1983s go into 28,000 plus? 1. So this goes into that one time, and I'll say what's left over. If I subtract, I did this ahead of time with my calculator. 8792 is left over. How many 6,561s go into, I'm looking at it like this again, go into this 8,700 number? 1 fits there. What's left over? 2231. So again, this is left over. So definitely a harder way to do the problem, but if we have to go in this direction. And then how many, where was I? I'll put a 1 here. And then what's left over? Well, I say if I take my 2231 minus 2187, I didn't do that one ahead of time, so let me get my calculator quick. So 2231 minus 2187, that's 44. So 44 is left over. How many times does 729 go into 44? 0. So this number divides into the leftover number, is what we're looking at. How many times does 243 go into this? 0. 0. So you go all the way down to the 27, because 27 goes into 44 once. I guess I could keep putting my 44s here just to follow my method. And then how many 27s are going to 44? 1. And what's left over? That's 17. And then how many 9s go into 17? 1. What's left over? 8. How many 3s go into 8? 2. With 2 left over. How many 1s go into 2? 2. So this is a crazy looking number. I'll write it up here. But I have 3 1s, 3 zeros, and a 1 1 2 2. And this is in base 3, so you have to put the base down there. That's a sub number, just a little bit lower. And do not put in commas. This is not in our system, so we're not going to put commas every 1,000 like we would. Just leave it like it is. Okay, definitely no commas. That's pretty crazy stuff for bases, but that's the general idea. Want some more problems? Let me know.